Okay, we're going to go quickly through this few examples here. And first of all, our first example. We did this type of problem before. Well, number two. Let's look at number one. There are 22 girls and 15 boys. If 12 of the students are to be selected at random, turn the probability that they're all girls. So the probability all girls equals the number of ways you could select the 12 from 22. And these are combinations because it's a group. It's the same group, whatever order that those 12 are in, it is the same group of 12. So it is a combination that we're looking at. And the ways to select any group of 12 from the 37. So these are the numbers, and put them together and we get approximately this number. Okay. This next one, this is the one that we did before. Determine the probability of being dealt 3 kings from a standard deck of 52 cards when 3 cards are dealt. Well, we did this before. We said that, okay, you have 4 kings to choose from your first card. No replacement. So now you have 3 kings left. You're assuming that it was a success. Now you have 3. So these are long run probabilities. And we're assuming it was a success. 3 on the second one out of 51 and 2 out of 50. So that's what we would have done before we knew how to count like this. Now, it seems like we're making it more complicated than it needs to be, but there's a good reason for some of these things, alternate ways to do calculations, especially when the numbers are really big. Now this one, we can view it as the number of ways to get 3 kings if you have 4 to choose from. So that would be all the possible numbers, the ways, the outcomes. Okay, that's the number of outcomes in the event space. Okay, the event is that you get 3 kings. And these are, again, combinations because, for example, over here, I listed the same 3 cards in 2 different ways. Okay, so it's not a permutation, it's a combination because this only counts for 1 right here. Even though it's arranged differently, it's still only 1. So that's why we're looking at combinations. So how many ways can you take 4 kings and pick 3 of them at a time? Well, it's 4, choose 3, like this. And how many ways can you take 52 cards and pick any 3? Well, that's what we'll divide by, and that's this number. Now, what's funny is if you go through the derivation of this, you will, it's a lot of work, but you will eventually end up with this product. And you can see the numbers in the product when you get to it. You should try that just to see if you can, just to practice breaking this down piece by piece. It's, it's just that 4 factorial over the 1 factorial, 3 factorial, and then divided by, so times, we would have, what was that, 49 factorial. Let's see. So that well, you know what? I'm gonna just do that. Come on, the long way. Okay, so let's just go back to this. You got the 52 factorial over 40. 3 would be 9. And then the 3 factorial like that. Okay, so that would give you 4 factorial over 3 factorial, and then times 49 factorial, 3 factorial with a 52 factorial, like that. So I'm going to get a lot of simplification here. Let's bring it down here. Let's see, that's a 4 times a 3 factorial, so that will get rid of that part there. And then this 49 factorial, I'm going to leave it. I'm going to write that 3, 2, 1, and then I'll make this 52, 51, 50, 49 factorial, like that. So you see that 49 factorial disappear, and then you see we have a 4, 3, 2, and a 52, 51, 50. Same as this number here. So that's kind of neat that you can see that happen. Okay, so anyway, let's continue. Our next page here. Okay, here we are on our next one. Jordy's wallet. Okay, now here's how this works. Has 8 bills, different arrangement of bills here, collection of bills. How many ways could they get if they pull out 2 bills? What's the probability that the 2 bills will be both $5 bills? Well, you have to calculate the number of ways of the 4 $5 bills that you could select 2 of those. Okay, number of ways to get the 2 bills from the 5. Or from the 4, and you have four bills, and you want to pick 2 at a time. So how many different ways can that happen? And we'll assume that we could tell the difference between the bills. One bill. So they're 2 different bills, even though we can't really tell the difference between them. If you get 2 5s, that counts as a selection. Any 2 5s. Now, how many? So then you're going to divide that by the number of ways you can select any 2 bills from the 8 bills in the wallet. So you might have a 5 and a 10. You might have a 20 and a 50. You might have 2 10s. You might have, you can only have one 20. So you might have a 20 and a 5. You might have a 20 and a 50. You might have a 20 and a 10. You might have 150 and 1.5. You might have, so there's a lot of things that could happen there. And that's the 8, choose 2 in the denominator. 8 chosen 2 at a time. And they are going to be combinations because of that. So you do the calculations, just throw in your numbers here. I've got this, my numerator. That's 4 5s, pick 2 at a time, and then any 8 bills, any 2 bills from the 8. So this is the probability of, this is the number of ways to select any 2 bills from those 8 that are there. Okay, and this, well, let's see, this one's small enough. I guess we can do the calculation. You got 4 factorial over 2, and then you have 8 factorial over 6 and a 2 factorial. So that's 4 factorial over 2 times 2, and then you have 6 factorial with a 2 and an 8 factorial, like that. And they, let's see, we're going to have this 4, 3, 2, 6 factorial 2, and then you have 2, 2, you have 8 times 7 times 6 factorial. So got it broken down as much as I can here. 4 and 2 makes that 8. And it looks like we just have left over here. Let's see, what do we got here? Another 2 and a 2. So it looks like I have a 3 out of 14. Okay, 3/14 probability. Okay, next one. You're going to pick 3 players at random. Maybe these will be the all-star players. Who knows, right? 3 players at random. And these are what you have to choose from. What is the probability that none of the players is a pitcher? Well, none is a pitcher, meaning that you have 15, you have 6 and 9 other players other than pitchers. So if you're going to pick 3 out of those 15, this is the number of ways you can do it. And then down here is the number of ways. You have 25 players, but you can pick 3 at a time. So this will be our answer here. I'm not going to go through that detail. The next one, 2 pitchers and an infield. So this is we can use our multiplication property to find the number of ways to pick the 2 pitchers and multiply by the number of ways to get the infielder. That gives us a number of ways to do both of those things. So this would be our answer. And see, I did not, I guess we could work that through. Let's see what we have here. I don't want to make this too long, but let's see, it's 10 factorial over 8 factorial 2, 6 factorial over 5 factorial 1, and down here we've got 25 factorial over 22 factorial 3 factorial. So we got 10 factorial over 8. Well, I'm going to start rewriting here just because I need to start simplifying. So that numerator, I'm going to have a 10 times a 9, 8 factorial, and then I got an 8 factorial and a 2. Here I have a 6 and a 5 factorial, 5 factorial 1. And that denominator is it's a 22 factorial with a 3 factorial, 3, 2, 1. And then underneath it would be a 25, 24, 23, 22 factorial. So we start doing our cancellations here. Let's see, we're going to get 22 factorial is gone, 8 factorial is gone, 5 factorial is gone. Let's see, we can do some other things now. Let's see, that'll be a 5. Let's see, we got a 6. Get rid of that, make that a 4. This 5 can go with the 25, makes it a 5. What else we got here? 2 with a 4 makes that a 2. And I think we're all done. Oh, we still haven't. Did I get rid of that 3 yet? No, I can't get rid of it. I'm stuck with that 3. Okay, so it looks like we have a 9 and a 3, and then down here we have a 5 with a 2 and a 23. So we got, what, 27 over 230. Okay, so that's the probability, 27 out of 230. Okay, next one here. Let's see. Okay, this is the jury selection, and I kind of went through this already. I'm just going to outline what I did. All women. Okay, all women. We have 22 to choose from. You're only going to take 12 at a time. Okay, actually, you are going to take 12 at a time because that's what you want. And they are combinations because we don't care which 12. If it's a certain group of 12, organization or arrangement does not matter. So it is a combination. Okay, order does not matter. And it will be 12 different women. Okay, so that in a numerator and a denominator is a way to select any 12 from the 39, any 12. This comes out to this number over here. Okay, part B, 8 women, 4 men. All right, well, here's the 8 women, and here are the 4 men. We're multiplying because this is the number of ways we can do both of these together. This is the number of ways to get the 8 women, and this is the number of ways to get the 4 men. I'm going to multiply them together to get the number of ways to do both of those things at the same time. Okay, which is what we want. We want to do both of them together. And then down here, just a number of ways to pick any 12 from 39. And this is our number that we get. Okay. Next one was 6 men, 6 women. So we got 17 men, 6 to choose from. 22 women, 6 to choose from. And we calculate our probability. The bottom, of course, is again the same 39, choose 12. And we get this number here. Okay. And finally, our last question, probability of at least 1 man. Well, you remember that's the same thing as the probability of 1. Well, it's the same as 1 minus the probability of no man. That's the complement again. At least 1 man is the complement of no man at all. I mean, of all the selections that can be made, if you collect all 1 or 2 or 3, all of that is considered one grouping, then the only other group is no man at all. So if you divide it into 2 groups like this, then the 2 groups make complements of each other. So you can calculate the probability of that larger group, the at least 1 man group, 1, 2, 3, or 4, or 5, or 6, just by taking probability of no man, the complement, from 1. And that's what we do here. Okay, I'm just going to take this right here, 1 minus probability of no men. And that's this number here. We calculated that in our first part. All women is the same as no men. And we end up with this number. So it's pretty likely that is going to happen, that you're going to get, I mean, think about what you're asking. At least 1 man. I mean, there are a lot of ways to do at least 1 man, or 2, or 3, or 4. I mean, that encompasses almost the entire outcome space, in almost the entire thing. I mean, there's only one other outcome, and that's no men. So you can see why this probability is so large here. It's very close to 1. So what it's saying is it's not likely to get a no-man jury. It's not very likely. It's more likely you're going to have at least 1 man on that jury. That's almost certain that there'll be at least 1 man on the jury. Once you start specifying, okay, if you say at least 2, then that's different, because now the complement becomes no men or 1 man. That's the complement now for at least 2. And that's a little bit more, we'd have to do a little more computation, but that's still a good way to go. I would use the complement again on that, probability of 1 man or 2 men. We could easily calculate that 1 at a time, or no man or 1 man. we can calculate that. It's just when you get to these other numbers like 1, 2, 3, 4, 5, or 6, then the probabilities get to be a lot more work to calculate. So, all right. Okay, we got one more here. Arrange 5 men and 6 women in a row of seats. You have 11 tickets. Find the probability that 3 women are seated in the first 3 seats and 2 men are seated in the next 2 seats. So we're going to use the counting principle, which is the multiplication principle of counting, and we're going to use our combination theory. So we want is the number of ways to the number of ways to select 3 women. That's this, whoops. Number of ways to select the 3 women from 6. That's over here. And then divide by number of ways to pick any 3 people from the 11, because you have 11. So that'll give you the probability of getting the 3 women. Okay. Then you're going to multiply that by probability of getting the next 2 seats, 5 men. So you have 5 men to choose from, and this is what you have. Okay, now notice what happened to the selection here. Because you already picked 3 right here, you already picked 3, you only have 8 left to choose from for that second probability. Okay, you have to assume that you already picked the 3 women out of the 8, out of the 11, so that gives you 8 left. You're going to choose 2 from that 8. So this is the second probability. It has not as many in the sample space because you have less people to choose from for that calculation for our denominator. So notice what happened there. And then, of course, I don't know, did I put an answer at the bottom here? I guess I didn't put an answer, but well, we could work through an answer. Let's see. Let's go ahead and work through this one. We got a 6 factorial over 3 factorial, 3 factorial over 11 factorial over 8 factorial, 3 factorial times 5 factorial over 3 factorial, 2 factorial over 8 factorial with 6 factorial and 2 factorial. Okay, so let's see what that gives us. 6 factorial over 3 factorial, 3 factorial times 8 factorial over 3 factorial, 11 factorial times 5 factorial, 3 factorial, 2 factorial times 6 factorial, 2 factorial over 8 factorial. Wow, okay, so lots of work to do here, but let's start. I'm going to leave that 6 factorial. Well, you know what, the 8's going to go away, so I guess you could choose this any way you want, but let's see. I guess I'll open up that 6. 6, 5, 4, 3 factorial. I got a 3 factorial under here. Along with a 6. That's the other 3 factorial. And over here, I have the 8 factorial. I got 3 factorial. And I have 11, 10, 9, 8 factorial. Over here, I got a 5 factorial. You know what? I better just go ahead and write that as 5, 4, 3 factorial. I got 3 factorial with a 2. And here I got 6 factorial 2 with an 8, 7, 6 factorial. Okay, so going to get some cancellations here. Let's see what we got here. Get rid of, well, that 3 factorial on that one. 8 factorial. Let's get rid of these big ones first. Okay. So I got rid of a lot of those. Let's see, here's a 3 factorial with that 3 factorial. And here's a 6 with a 6. What else we got here? Let's see. I guess we could do this 5 with this 10, making that a 2. That in there. Okay, and what else can we do? Let's see, that 2 with that 2 and that 4 go away. That 2, that 8 makes 4. That 4 with that 4 cancel. What else? 7, 9. Okay, so let's take inventory here. Let's see what we got left. We still have 5. We got this 3 factorial, which so that's 3 times 2. And that's 8 up in the numerator. Denominator, it looks like we just have an 11, a 9, and a 7. Okay, so finally, it's, what is this, 30? Well, actually, I didn't see that 3. Get rid of that 3 with the 9, so this is 10 over, let's see, 21, well, 33 times 7, which is what? 10, 21 to 31 with a 10. Okay, so went through that kind of quickly, but that should be our answer. 10 out of 231. Okay, so that's how you can use combinations to do probabilities. I just want to add one thing here. Sometimes you have options. You don't have to do a problem thinking about combinations. This is one way to do your counting. And sometimes it is faster, it is better, but not always. I don't want you to forget about what we did before. We could view the same problem this way, over here. And I got some scribble in here, but I wanted you to see. We're going to select 5 people. Okay, so you have these 5 men and 6 women to choose from, and you want the first 3 to be women. So what's the probability that you get a woman on your first draw? You can look at it that way. If it's random, what's the probability she show up on the first draw for the first seat? Well, 6 out of 11. Then you want another woman for the next draw. Well, you only have 5 left out of 10. And another one for the next one, 4 out of 9. Then you want to start with your men. Well, you have 5 men, but you only have 8 total to choose from because you already pulled 3 out. The 3 women are gone. So you have 8 people total left, 5 of whom are men. And then, assuming you picked one, you still have 4 men out of 7. Find this product, you'll get this number. So notice this is the same number we got down here. It's actually a lot less work. So can view the problems in a couple different ways now. All right.